given any two non-zero vectors, a vector and b vector, shows that the magnitude of the cross product of two vectors a and b squared is equal to the magnitude of a vector squared multiplied by the magnitude of b vector squared minus the dot product of two vectors a vector and b vector squared. So let's consider the left hand side, and it is given in a data booklet that the magnitude of cross product of two vectors is equal to the magnitude of the first vector multiplied by the magnitude of the second vector and multiplied by the sine of the angle between them. And since this magnitude is squared, so this also should be squared, and it is equal to a vector magnitude squared, b vector magnitude squared, sine squared of theta. And we know that sine squared is 1 minus cosine squared. It's the main trigonometric identity, and hence it becomes a vector magnitude squared, b vector magnitude squared multiplied by 1 minus cosine squared of theta, and it is equal to a vector magnitude squared, b vector magnitude squared minus a vector magnitude squared, b vector magnitude squared, and multiplied by the cosine squared of theta. And we know that a magnitude multiplied by b vector magnitude multiplied by cosine of the angle between these two vectors, it's dot product of two vectors formula. This formula is also given in a data booklet, hence it becomes a vector magnitude, b vector magnitude squared, a vector magnitude squared, b vector magnitude squared minus a vector dot product b vector squared as required, and it's the right hand side as required. So this statement is true. Or we can consider the left hand side and consider the right hand side, and we can see that the right hand side is equal to magnitude of a vector squared, magnitude of b vector squared minus, and using a formula for the dot product, it is also given in a data booklet, it becomes a vector magnitude, b vector magnitude, cosine of the angle between them and squared, and hence it becomes a vector magnitude squared, b vector magnitude squared minus a vector magnitude squared, b vector magnitude squared, cosine squared of theta, and it becomes a vector magnitude squared, b vector magnitude squared multiplied by 1 minus cosine squared theta, and again the main trigonometric identity 1 minus cosine squared is sine squared, so it becomes a vector magnitude squared, b vector magnitude squared, and multiplied by sine squared theta, and hence since the left hand side is equal to the right hand side, this statement is true. And that's all for this question.